Hi, this is Jim Berthold from OLI Systems. Today's video is about how to modify the chemistry in the OLI engine for Unisim Design. The reason we want to modify the chemistry is sometimes we can create species that are thermodynamically stable. Primarily, we're talking about solids. And these solids are probably or highly unlikely to form in real time. For example, they may form under geological conditions or require a catalytic reaction to form. So we're just going to go through and modify the chemistry a little bit. Currently I'm using the OLI engine 11.5 inside Unisim Design R492. And we're going to go through a brief review here of how I create models. I go into the fluid packages first, click the add button. We will have to scroll down to find the OLI engine, and there it is, OLI electrolyte. This brings up a sub-manual panel here. For this example, I'm going to select MSE, and I'm going to go right into the component list. Okay. We will pick the OLI electrolytes. Since it is an OLI model, we always start with water. Okay. And I'm going to add some components here. I'm going to add carbon dioxide, calcium chloride, magnesium chloride. Simple model, only 4 components. And I'm going to go ahead and close that. I'm actually going to initialize the electrolytes environment. We're going to do that right now. Okay, it's actually done. I can view the electrolytes in the trace window. Here it is. And you can see this is the actual electrolyte chemistry. The problem is, I'm looking in the file here. It's hard to read these files here, but we have a lot of solids here that are probably unlikely to form. For example, we have hydrochloric acid hydrates. These will form at high concentrations of hydrochloric acid and at low temperatures, unlikely in this particular example. I also have a bunch of magnesium hydrates, calcium chloride hydrates. I also have something called aragonite, which is a form of calcium carbonate, which is less thermodynamically stable than calcite. I should have some other species in here as well. Hard to read the list here, but we have a selection tool. And again, once the model has been created, I can go into solid selection here. And then I can look for any and all solids I want to turn off. Okay. I can include all the solids, which is the default. I can exclude all solids, or I can exclude all solids and leave the scaling tendencies on. That's a topic for a different lecture. What I'm going to do first is exclude all the solids, okay? And then I'm only going to turn on the solids I'm interested in this case, calcium carbonate. Okay. Maybe I'll put on the hydrates here. Not the hydrates, the hydroxides and oxides. Okay. I might want some of these other species here as well. And I'm done. Okay, I'm all ready to run. I can just go into the environment basis and create a stream. Okay, this part should be very familiar with Unisim users. I'll go into composition. I'm going to switch my basis to mole flows, just because I think that way. 55.508 moles of water, by the way, is 1 kilogram of water. And I'll just put in a couple of these other guys. Now, by removing those solids, I don't remove these inflows. So these inflows are still here. Okay. Unfortunately, there's no way to remove these from the model. This is a design improvement that we'll have to add to Unisim Design at one point. Okay, I'm running. There it is. It calculated. I can look at my compositions. I can look at my solid phases. Didn't get any solid phases in this particular case here. but you saw how fast it ran. The more solids you add to the model for possible inclusion, the longer the model will take to run. So this is just a quick way of how to modify the chemistry to remove solids. Can't remove the inflows, but it can remove the solids, and that will speed up the calculation. If you have any questions, of course, please contact OLI via our portal at portal.olisystems.com. Thank you.